This is the introduction tab of Grams tool. It explains what the Grams tool does and provides brief description for each of the tab. We're going to go down on this tab and click on the launch tool. This is the input screen of Grams tool. We have to put couple of information such as county name, roadway information, and cost information. As we can see, it already is showing some error message here and here. When we will put a county name, this error message will disappear. We're going to put Story County, and here we can see it picked the historical data on these values. Now this is the roadway network system size. We're going to assume it's about 400 miles. Average roadway width about 22 feet. Percentage of roadway with poor ditch condition, say it's about 40%. If the user want, they can put their own LA abrasion and percentage of fines content information on these two tabs, these two cells, but we're not going to do that. There the user need to put some cost information. We're going to assume the purchase cost is about $5 per ton. Couple of the counties have crushing cost. We're going to assume it's 0 for Story County. The hauling cost we're going to assume about $3. The dump truck cost for dollar per ton mile is about $0.3. One-way dump truck travel distance about 20 miles. And placing, grading, and miscellaneous cost we're going to assume about $2. If we go down, we can see that it shows the minimum acceptable roadway thickness. It's about 1.5 inches by default. If the user wants, they can override it and put a different reliability level here, minimum acceptable as 2 inches or 1 inches or something different. If we want, we can reset all the values here, but we're not going to do that. We're going to go to the analysis page. Here the user need to put inventory information of the roadway network. We're going to assume over 5 inches of thickness is about 5% of the roadway network. 4 to 5 inches of thickness about 10% of roadway network. 3 to 4 inches of thickness about 15% of roadway network. And 2 to 3 inches of thickness about 30% of roadway network. We can see that the annual gravel loss based on our beta regression model is about 0.86 inches. If the user wants, they can put their own gravel loss values if they do not agree with this estimation. Now the user need to put the estimate rock requirements button. They can also go back to the previous screen or reset all the values with these buttons. We're going to put the estimate rock requirements and go down. We can see the minimum resurfacing required is about 12.5 miles. What does this mean? If we go back to the previous screen, we specified a minimum acceptable roadway thickness of 1.5 inches. This 12.49 miles means after 1 year, approximately this miles of the roadway network will have less than 1.5 inches of thickness that we specified in previous tab. Here we can see the tons per mile requirement and associated annual cost and breakdown material cost and roadway reliability for each of the conditions. For example, it says about 75% reliability. What does it mean? It means approximately 20% of the roadway will have unacceptable performance when we put 500 tons per mile, and 75% will have our desired roadway performance. Now we can proceed to the final report. This shows the most critical system size as we discussed this previously. It's the minimum acceptable thickness of 1.5 inches. We will have about this much of road with less than minimum thickness. And these are our range of options as we have seen in the previous slide. For different level of tons per mile, we can see the rock requirements and total and material cost with reliability and performance information. This 75% is still the same. It indicates with 500 tons per mile rock application, approximately 25% of the roadway network will have unacceptable behavior. The rest 75% will have satisfactory performance above. These are our graphs of risk and reliability, cost and TPM graph. If we want to read this graph, we have to start from x-axis and go straight to the vertical direction. For example, if we pick from 500 TPM and go up, we get to the orange line. This indicates the cost for 500 TPM. We can read this value right from here. It's about $2.5 million. And we go straight right up. We hit this yellow line that shows about 30% roadway system will be at risk. And this shows the risk and total cost curve for different TPM levels. If we go to this graph on the right side, it shows the same graph but for the material cost, not the total cost. So we can see that for 500 TPM, the material cost is approximately $1 million. Here the cost is about $3 million, the total cost. And if we go up, we can see that the system at risk is still approximately 30%, which is the same. And this is the best case scenario. That means we're resurfacing the entire 400 miles of the roadway network. If we go down, we can simulate the range of options. If the user wants, they can put 25% of the roadway network. That means about 100 miles of the network that they're going to resurface. And it would show the risk, reliability, and TPM graphs for this condition. So we can see that for 500 TPM, we have to spend about $1 million, and the risk would be approximately less than 25%. And this is the total cost to resurface this 100 miles or 25% of the network. And this is the same graph, but it shows the material cost. So it's less than, for 500 TPM, it's about $0.3 million, and the risk is still the same as the left side. And if we go down below, we can find the roadway life cycle. This is a hypothetical condition. If no resurfacing is conducted, how long it would take for the entire roadway network to go down in the unacceptable condition. We can say approximately after 30 months, if we do nothing, the entire roadway system will be in unacceptable condition. The unacceptable condition means less than 1.5 inches thickness that we specified previously. And again, this risk or reliability means the 75%, the reliability, it means about 25% of the road will have unacceptable performance. For now, this is the overall basic using guidelines for the GRAMS tool. Thank you for your time.